Hello, welcome back from break. Hope y'all slept enough. So yeah, we're doing 5.1 fundamental identities.
Thank you.
Identities.
Identities. All right. So. All right. So these are things that we already know. Does everyone have their unit circle out?
I saved it. I didn't throw it away.
Thank you. Thank you. Anyone still need unit circle?
I'm a star student.
Okay. Right here. I went and made extra copies. Come grab one if you need it. Okay. Your reciprocal identities are up there. You need your identities for your x, y's, and r's. Okay. See this piece right here? The quotient identities. The quotient identities. We're going to actually go over this one here. Eventually, just not today. Now, Pythagorean identities is x squared plus y squared is equal to 1. Right? X squared plus y squared is equal to 1. Or x squared plus y squared is equal to r squared, right? From my unit circle, my radius is 1. Yes?
You didn't put the homework up.
It's 7 through 12 all?
I don't have it.
You didn't put that out there at all.
7 through 12 all. I don't know who didn't pass out, but...
No, the...
Hey, mister!
You didn't put it on the screen.
Can you put one more of these?
Which one?
The slide.
Here you go. Okay, so now I want you guys to pay close attention to what I got right here. These negative angle identities. We've gone over it way back when. We've gone over it a while ago, but I want you guys to actually look at this and have this because we're going to reference this here soon. Okay? We're going to go back over this here soon.
Do we have homework?
Yes, you do.
Already. What's the thing?
You didn't put the thing up there.
You
though.
didn't put the...
Yeah, the PowerPoint, I couldn't find it. They had issues with my hard drive here. So, what did I say it was? It was, yeah, 7 through 12 all.
Okay, but is it like
7 through 12. So it's 5.1a, 5.1a, 7 through 12 all. So, sorry about that.
5.18.
5.1a. All right, so let's take a look down. So we know tan. We know tangent. Tangent is what over what?
Y over x.
Y over x, very good. Tangent is going to be y over x. Ah.
that stinks. The Christian trying to film challenge?
So it still doesn't want to work with me.
Right.
Okay, so we know tan
And action.
is y over x, right?
Yeah.
Tangent's going to be y over x. So I know a couple things already. I know that I'm going to have y, I'm going to have x, and I'm going to have r. Now, if I'm looking at this information right here, theta is in quadrant 2. Because one of these here is going to be negative, in quadrant 2, which one is negative?
Quadrant 2?
In quadrant 2.
Y.
X.
Oh, shit.
In quadrant 2. So if we were to look at my unit circle, it goes plus, plus, minus, plus, minus, minus, and plus, minus. Right?
Yeah.
So quadrant 2, the x value has to be negative. So in quadrant 2, so this is y over x. So my y value is 5. X value is?
-3.
And how do I solve for r?
Pythagorean theorem.
Pythagorean theorem, very good. So I'm going to do the Pythagorean theorem. So my Pythagorean theorem, so in quadrant 2, it's going to look like this. I'm going to have that my r is here, my x is -3, and my y is 5. So using Pythagorean theorem, which value am I solving for now?
R.
So I'm solving for the r, so let's go ahead and plug in my values. So it's going to be -3 squared plus 5 squared is equal to r squared. 9 and 25 gives me 34. So 34 is equal to r squared. So r is equal to square root of 34. Now, is my r ever negative?
No.
My r is going to be negative, never negative. So this is rad 34. Now, what is the question asking for? So part A, I kind of deleted it from my side. Part A says find the sine of theta. Does it say secant?
Says secant.
Oh, it says secant? My bad. Now,
Yeah.
secant theta. Secant theta. Secant is what over what?
Is R over X.
R over x, right? R over x. So my r value is rad 34. My x value is, so my whole thing comes out to be a negative rad 34 over 3. Now, if you notice, all I did was I moved the negative from the denominator to out front. This means the exact same thing as this. I just moved it. So it's fine. This is, both of them is actually correct, but negative out front is always a good thing. Okay? So you either want to have it in the numerator or out front of my fraction. Make sense?
Yes.
Okay? Yes.
So the bottom one can be a negative since it's R can be.
Yes, r can never be negative. R is always positive. So it could be, so like on this case right here, it could be, but the problem is I just don't leave it there. Just for the sake of, especially since we have like a multiple choice test, you're not going to have a negative in the denominator. It's either going to be on top or in front. Okay? All right, so let's take a look at the next one. So sine. We know sine is what over what? Y over r. So it's y over r. And my y value, what was my y value? 5. My r value was?
Rad over 34.
Rad 34. Now, can I leave it like that?
No, you can have the rad.
Nope. So you have to rationalize. So I'm going to multiply top and bottom by?
Rad 34.
5 rad 34 over 34.
Where's the same thing?
Huh?
What? Never mind.
Are they the same?
No.
It's equivalent, but I just cannot leave my radical in the denominator. All right, so part C. Oh, it says B again. I don't know why. Anyway, all right, so now, see this negative right here?
Yes.
That's negative on the inside, right?
Uh-huh.
Okay, so now I need to go back and see what does this do? What does this do? So I'm going to back up to my identities. That was cotangent of negative theta, right? Cotangent negative theta is right here. So it's going to be the same as cotangent, but I put a negative in front. Okay, so I'm going to change it from this to this over here.
From what? From what?
So on this one, for this identity, it's going to be the same as saying negative cotangent of theta. So I find the cotangent of theta, but then I take the opposite of that value. We know that cotangent is what over what?
X over R. I mean Y.
X over
Y.
X over Y. X over Y, right? What was my X value?
-3.
So it's going to be negative 3 over, what was my y?
5.
5. But if this is my value here for the cotangent, it now says that I have to have a negative of my negative 3 over 5. Because I have a negative, so this is an opposite right here. This one right here means it's going to be the opposite of my cotangent.
So it'd just be positive?
Yes, my cotangent is a negative here. And I take the opposite of that. So that means it's going to end up with a positive 3 over 5. All right, so questions? No questions on that? Let's try this next one then. Oh, is that the next example? Uh-oh. There we go. Guess what? We're done. All right, so I'm going to leave it off for that one. That means right there, don't forget like and subscribe, right?
Don't forget to like and subscribe, share with your friends.
Yes.
Make sure to rate this video.
I know, right?
Add it to your favorites.
Let me see. 100 likes. What are we going to do?
Extra credit.
Christian's going to do a dance for that one.
Yeah, for sure.